Hi. So in this class, I'm going to start direction cosines of a directed line. What is the definition of direction cosines? In short form, DCs of a directed line. So first of all, what is the meaning of directed line? Okay. So already you are familiar with vectors. Okay. So what is the geometrical meaning of a vector? So geometrically a vector is nothing but it is a directed line segment. It is a directed line segment. So directed means what? That segment has direction. Okay. Segment. As it is a segment, it has a fixed length. So that means this quantity, directed line segment, that quantity has direction as well as what? Length. So that's why that directed line segment can be taken as what? A vector. That is geometrical meaning of a vector. Now what is a directed line? Means it is a line having a direction, a particular direction. See, this is suppose say L. L is the directed line. To say this L is a directed line, it must has a direction, but it has no fixed length. Okay, that means its length is infinite. Because what is the length of the line? It is infinite only, no? So directed line means it has a direction, but length is not fixed value. It is not a fixed value. It is what? Whose length is infinite. It is meaning what I mean. Not a fixed value means it is not the meaning that it is a variable. It is a whose length is infinite. Okay, its length is not finite, its length is infinite. Now you understood. Directed line means it is a line, it has a particular direction. Okay, so to discuss the definition of direction cosines, first you consider coordinate system. Okay, so this is the origin and this OX is the what? Positive X, and negative X this side is there, and this OY is what? Positive Y, and this OZ is what? Positive Z. So OZ, how we have to imagine? In this. Okay. Now let L is the line L. Okay. Suppose it is a directed line. It is a directed line. So let P is a point on this line. Let P is a point on this line. Now what is the direction? From O to P only the direction. Okay. So suppose this directed line makes an angle alpha with the positive x-axis. Okay. Next angle beta with positive y-axis and angle gamma with positive z-axis. That means this line makes angle alpha, beta, gamma with what? OX, OY and OZ respectively. Then these three angles, alpha, beta, gamma, these three angles are called directed angles. These three angles are called what? Directed angles. Okay. And next, if these three are the directed angles of L, or you can write OP, okay, either L or OP, okay, then cosine alpha, that is cos alpha, cosine beta, that is cos beta, cosine gamma, that is cos gamma, these three are called direction cosines. Direction cosines. Direction cosines of OP. Okay. Usually these direction cosines of a line OP are directed line particularly here. So usually direction cosines are denoted by small letters L, M, N. So thus L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma. Okay. So this is the definition. What is the definition? If alpha, beta, gamma are angles made by the directed line OP or L with OX, OY, OZ, or you can write positive coordinate axis, then alpha, beta angle, alpha, beta, gamma, these three angles are called what? Directed angles of the OP. And cosine alpha, that is cos alpha, cos beta, cos gamma, they are called what? Direction cosines of OP, or in short form DCs of OP. So usually these direction cosines are denoted by small letters L, M and L. So thus L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma. These are the standard symbols. Remember, wherever this DCs of a line is appear, you have to denote those DCs by what? L, M, N. Okay, these are the three standard symbols. Okay, suppose if you consider a point P dash, a point P dash, it is here, and say suppose the direction is like this, OP dash. That means instead of directed line, I am considering the straight line L only. Now I am considering the straight line L only. So for the straight line L, how many directions it has? A line has two directions opposite to each other only, na? So for this line, one direction is OP direction, another direction is OP dash direction. Okay, OP dash direction. So as this line has two different directions, then it has two different sets of direction cosines. This is the one of the set. This is the one of the set of direction cosines of the line L. Now how to find direction cosines of another set of direction cosines of this line? That means how to find direction cosines of OP dash. So clearly as OP, see, as OP makes an angle alpha, then clearly OP dash makes what angle? Pi minus alpha only, na? OP dash makes an angle pi minus alpha with what? OX. So for OP dash, it makes an angle pi minus alpha with OX, pi minus beta with OY, and pi minus gamma with OZ. That means OP dash makes an angles pi minus alpha, pi minus beta, pi minus gamma with positive coordinate axis. Do you understand how we got pi minus alpha? Because this whole angle is a straight angle. Already here alpha is occupied, so remaining angle will be what? 180 minus alpha. Similarly, that OP dash makes an angle pi minus beta with OY, and with OZ pi minus gamma. So for OP dash, what are the directed angles? Pi minus alpha, pi minus beta, pi minus gamma. So obviously the direction cosines of OP dash will become what? Cos pi minus alpha, cos pi minus beta, cos pi minus gamma. Am I correct? Here alpha, beta, gamma are directed angles, then automatically cos alpha, cos beta, cos gamma are direction cosines. But here what are the directed angles? Pi minus alpha, pi minus beta, pi minus gamma. Then obviously direction cosines will be what? Cos pi minus alpha, cos pi minus beta, cos pi minus gamma. So we know that cos 180 minus theta is minus cos theta. Am I correct? Because 180 minus theta lies in second quadrant. So for 180 minus theta, so as it is lies in second quadrant, cos is a negative. And for 180 minus theta, for 180 cos function no change. Okay, so then cos 180 minus theta becomes what? Minus cos theta. So cos 180 minus alpha is what? Minus cos alpha. Cos 180 minus beta, minus cos beta. Cos 180 minus gamma is what? Minus cos gamma. As I'm denoting cos alpha, cos beta, cos gamma by L, M, N, then automatically as cos alpha denoted by L, minus cos alpha should be denoted by what? Minus L only, na? So then these three quantities becomes what? Minus L, minus M, minus N. So thus the direction cosines of OP dash are what? Minus negative L, negative M, negative N. So minus L, minus M, minus N. Okay. So here if you observe what directions of OP and OP dash, they are of opposite direction only. Na? Direction of OP and OP dash, they are of opposite direction. Na? That means in one direction, direction cosines are L, M, N. Then another direction, that means opposite direction. Then what are the direction cosines? Minus L, minus M, minus N. That means just you change the signs. Okay. So in one direction, direction cosines are L, M, N. Another direction, what you will get? Minus L, minus M, minus N. Okay. So hope you understand. Next. So here, one more thing you have to remember, one more important point. Suppose if the given line is not passing through horizon, how to find their direction cosines? Suppose the given directed line. If the given directed line, if it is a directed line, it has only one set of direction cosines. If it is a line, it has two sets of direction cosines. One direction if it is L, M, N, another direction obviously minus L, minus M, minus N. Okay. Now we are talking about what? Directed line. So clearly this directed line is not passing through horizon. Then how to find direction cosines of this line? Then you draw the directed line parallel to AB and passing through O. Okay. So parallel to AB passing through O. So this is the directed line parallel to AB and whose direction is same as AB. Suppose P is a point here. Then the direction cosines of AB is same as direction cosines of OP. Here the direction cosines of AB is same as direction cosines of OP. Okay, the direction ratios of direction cosines of AB is same as the direction cosines of OP. So same, suppose if it is makes an angle alpha, beta, gamma with positive X, positive Y, positive Z, okay, then that alpha, beta, gamma are called directed angles of OP as well as directed angles of AB. Okay, because these two are parallel na, as this line makes alpha with OX, automatically AB also makes alpha with OX only. Okay, so then automatically the direction cosines of this OP is same as direction cosines of AB. So if L, M, N are direction cosines of OP, then the direction cosines of AB is also L, M, N. Now I am going to prove one important result. Okay, that is relation between direction cosines of a given line. Okay. Okay. So L is the given line. Suppose L is the given line. So you can consider any one of the direction. Okay. I am considering this OP direction. Suppose P coordinates are X, Y, Z. P coordinates are X, Y, Z. Suppose OP length is R. OP length is R. What I consider P point is X, Y, Z. So it is relation between direction cosines. Okay, so P is a point X, Y, Z, and I'm assuming the OP distance is R. That implies that what is OP distance? Generally, if you use distance formula, root over x square plus y square plus z square. So which is equal to R. Let it be 1. So suppose this OP line makes, an angle alpha with positive x-axis. Now through P, this is the point P, whose coordinates are x, y, z. So through P you draw a perpendicular on x-axis. Okay, so let it be, this is M. Obviously this OM length will be what? No? X only, no? Now from this right triangle, this is clearly right angle triangle, no? Triangle OPM. So clearly from right angle triangle OPM, okay, find cos alpha, because we have to find relation between direction cosines. Okay, so what are the direction cosines? L, M, N, or cos alpha, cos beta, cos gamma. So find first cos alpha value. So from triangle OPM, cos alpha is equal to, in this right triangle, adjacent side is what? OM. Hypotenuse is what? OP. So cos alpha is equal to adjacent side OM. What is OM length? X. By hypotenuse. What is the hypotenuse? R. So cos alpha, what you got? X by R. Similarly, suppose if this line makes an angle beta with OY, okay, then same way draw the perpendicular on y-axis. You can easily prove cos beta is equal to y by R. And similarly, we can easily show cos gamma is equal to z by R. What is gamma? Gamma is angle made by the line with OZ. This alpha, beta, gamma are the standard symbols, remember. Okay. So cos beta is y by R, cos gamma is z by R. So now you consider L square plus M square plus N square. This is consider. So consider L square plus M square plus N square. So L is nothing but cos alpha. So L square is nothing but cos square alpha plus M square. M square is nothing but cos square beta, because M is cos beta. N square. N square is nothing but cos gamma whole square, nothing but cos square gamma. So what is cos alpha? X by R. Cos square alpha is X by R whole square. That means what you will get? X square by R square. Cos square beta, what you will get? Y square by R square. And cos square gamma, what you will get? Z square by R square. So what is LCM? R square. So if you take 1 by R square is common, or if you take R square is LCM, what is the remaining factor left here? X square plus Y square plus Z square. So 1 by R square into, from equation 1, what is root over X square plus Y square plus Z square value? R. Then R square is nothing but what? X square plus Y square plus Z square only. Na? If you square on both sides, what you will get? X square plus Y square plus Z square is equal to what you will get? R square. Am I correct? Okay, you take this as the only equation 1. So just what I did, square this relation. What we got? X square plus Y square plus Z square is equal to R square. So here I am substituting this X square plus Y square plus Z square value is how much? R square. So 1 by R square into R square, what you will get? 1. So thus, what you got relation? L square plus M square plus N square is equal to 1. Or you can write L is nothing but cos alpha only, na? Cos square alpha plus M is nothing but cos beta only, na? Cos square beta plus N square, nothing but cos gamma whole square, na? Cos square gamma is equal to 1. So this is the important relation. So you have to remember throughout this topic, L square plus M square plus N square value, that is sum of the squares of the direction cosines of a line is equal to what? 1. If you take other direction also, you will get minus L, minus M, minus M. Sum of the squares means minus L whole square plus minus M whole square plus minus N whole square. Nothing but L square plus M square plus N square. Again, that value is also what? That value is also what? 1. If you take any direction of the line, you will get sum of the squares of the direction cosines of a given line is always equal to what? 1. Suppose if the given line not passing through origin, then you draw a line parallel to that line passing through origin. Then you will get this cos square alpha plus cos square beta plus cos square gamma. Okay, now I have one doubt. Now my doubt, one doubt. See here, what if R value 1? What if R value is 1? What if special case? Special case. So will you note down? So pause the video, you can note down this, okay? So special case, what if R value is 1? R value is 1. So if R value is 1, if I substitute that R value is 1 in cos alpha, cos beta, cos gamma here. If I substitute that cos R value 1 in this, if I substitute R value 1 there, what I will get? Cos alpha is equal to x by 1, which is equal, implies that x is equal to cos alpha. Or I can write cos alpha is L only, na? And similarly, what I will get? Y is equal to M or cos beta, Z is equal to cos gamma or N. So if R is equal to 1, then P is equal to P coordinates X, Y, Z. This P coordinates X, Y, Z becomes what? L, M, N. Am I correct? Okay. What are L, M, N? They are the coordinates of P. Also, what are L, M, N for line? They are the direction cosines of the line. Okay, that means if R is 1, then the coordinates of this point P becomes what? Direction cosines of the line. So if a line is passing through origin, then the coordinates of the point which is at a distance 1 unit, from the origin. The coordinates of the point on the line L, which is at a distance 1 unit from the origin, is nothing but direction cosines. The coordinates of the point P, which is at a distance, the coordinates of the point which is lies on the line L, which is at a distance 1 unit from the origin, then those x, y, z coordinates of the point P becomes direction cosines. So it is possible only if the line is passing through origin. Okay, if the line is passing through origin, then if you take a point on the line which is at a distance 1 unit from the origin, then its coordinates are nothing but direction cosines of the line. Obviously, line has two different directions now. In one direction, 1 unit, you got L, M, N. In another direction, if you take a point which is at a distance 1 unit from the origin, so then the coordinates of this P dash becomes what? Minus L, minus M, minus N. So this is also another set of direction cosines of the line, because this OP direction and OP dash direction are opposite direction. So here, if you got in this direction, L, M, N are the direction cosines. In this direction, what you will get? Minus L, minus M, minus N are the direction cosines. So that means if a line is passing through origin, then the coordinates of a point on the line which are at a distance 1 unit from the origin, they are nothing but direction cosines. Only if the line must passing through origin. If it is not passing through origin, suppose if a line is not passing through origin, then the points on this line which are at a distance 1 unit from the origin, they are not at all direction cosines of the line. Okay, only if the line passing through origin, this will happen. Okay, clear? But this is an important result. L square plus n square plus n square is 1, or cos square alpha plus cos square beta plus cos square gamma is 1. Okay, and one more important point, special case, what I have taken, if r is equal to 1, what I got? The points on the line which are at a distance 1 unit from the origin, the coordinates of those points are nothing but direction cosines of that line. Okay, only the line must pass through what? Origin. So if you want, you can take note point. If the line L passing through origin, then the coordinates of the point on the line which are at a distance 1 unit from the origin gives direction cosines of the line. In bracket, as line has two different directions, there are two different sets of direction cosines. And also, there are 2 points on the line which are at a distance 1 unit from the origin. Over. Next. So special case 2. The special case 1 when r is equal to 1. Next, special case 2. Special case 2. Okay. Here, what is OP distance? R. What is OP distance? R units. What are the direction cosines? LMN. So LMN are direction cosines of OP. Okay. Then the coordinates of P, X, Y, Z in terms of direction cosines and distance. That means you know the distance from the origin and you know the direction cosines of this line. Then how to find coordinates of P? Again, from this area, from this relation, what is the x value? If you cross multiply r, what you will get? R into cos alpha. X value is what? R into cos alpha. If you cross multiply x is equal to what you will get? R into cos alpha. Nothing but x is equal to r into cos alpha is nothing but L only, na? So that means x coordinate becomes LR. And obviously y coordinate will become what? MR. And z coordinate will be NR. So now you tell me, what about P dash? Here P dash is also suppose R units, because there will be obviously how many points will exist? 2 points will exist now. So there will be 2 points on the line which are at a distance R units from the origin. So 1 point coordinates you got LR, MR, NR. Obviously P dash coordinates becomes what? P dash coordinates becomes what? P dash coordinates becomes obviously minus LR minus MR minus NR. So if you know just OP length and direction cosines of the line, then you can find, using this as a formula, you can find coordinates of the point P. Here remember the line must pass in through origin, then only we can do like this. Okay. So for example, suppose the direction cosines of this line, the direction cosines of the line are 1 by 2, 1 by 2, 1 by root 2. The direction cosines of the line are 1 by 2, 1 by 2, 1 by root 2. Then find the coordinates of the points on the line L, then find the coordinates of the point on the line L which are at a distance 5 units from the horizon. Which are at a distance 5 units from the horizon. So obviously there will be 2 points on the line which are at a distance 5 units from the horizon. Okay. So that means here what is R value is given 5. OP is equal to R is equal to how much? 5, which is same as OP dash 2. And here L, M and R what? 1 by 2, 1 by 2, 1 by root 2. Then what are the coordinates of point P? LR, MR and R. That is 1 by 2 into 5, 5 by 2. Next 1 by 2 into 5, 5 by 2. Next 1 by root 2 into 5, 5 by root 2. So obviously the coordinates of P dash becomes what? Obviously the coordinates of P dash becomes what? Just change the signs. Just change the signs of these coordinates. Then what you will get? Minus 5 by 2, minus 5 by 2, minus 5 by 2. So it is not the meaning that P dash coordinates are always negative. Okay. So just change the signs of coordinates of P. Suppose here direction DCs of the direction cosines of the line are given 1 by 2, 1 by 2 minus 1 by root 2. Suppose it is given like this. Then the coordinates of P becomes what? LR means 5 into 1 by 2. MR means 5 into 1 by 2. NR means 5 into minus 1 by root 2 minus 5 by root 2 will get. Obviously obviously the coordinates of P dash becomes minus 5 by 2 because here you got 5 by 2, here minus 5 by 2. Here 5 by 2, minus 5 by 2. Here minus 5 by root 2, then here obviously what you get? Plus 5 by root 2. Just changing the sign. Hope you understand. Okay. And also one more important point here. If OP length is 1 and OP dash length is also 1, OP length is 1 and OP dash length is also 1. Okay. Then the coordinates of P becomes what? L, M, N. Then the position vector of P becomes what? OP bar is equal to L into I cap plus M into J cap plus N into K cap. Then what you will get? Magnitude of OP bar square root of L square plus M square plus N square. But what is L square plus M square plus N square? Well, just now we proved its value is 1. So that means what is the magnitude of this vector OP bar? 1. So as the magnitude of this vector is 1, then what kind of vector it is? What is the name of this vector? As magnitude of this vector is 1, what is the name? Unit vector. Unit vector. Okay. So here this L, M, N are what? Direction cosines. Sorry, direction cosines of what? OP bar. Am I correct? Because P point is LMN means, so LMN are direction cosines of the line L means in this direction. Obviously for this vector also, OP bar vector also, because the direction of OP bar is same as the direction of this OL, this direction. Okay. So in this direction, the direction cosines are LMN means the direction cosines of OP bar also what? LMN only na. So this L, M, N denotes what? Direction cosines of the vector OP bar. And if I take its magnitude, what I got? 1. That means what is the name of this vector? Unit vector. That's why in vectors, if you want to find direction cosines of any given vector, you are finding first what? Unit vector. You are finding what? Unit vector. And the coefficients of this I cap, J cap, K cap gives direction cosines of that vector. Okay. So if you want to find direction cosines of any vector A bar, what you are doing? Finding A cap. And the coefficients of I cap, J cap and K cap in A cap are nothing but direction cosines of A bar as well as A cap. Okay. So because this is the reason. If L, M, N are the direction cosines of a line L, then OP bar denotes what? It is a unit vector in the direction of L. Means in this direction. In opposite direction, what you will get? Minus Li cap, minus Mj cap, minus Nk cap. Okay, understood? So look at some problems based upon direction cosines of a line. Okay. Suppose if a directed line makes an angles, if the directed line makes an angles 30 degrees, 45 degrees and gamma with positive coordinate axis. That means with OX, OY, OZ. Then find gamma value. That means find angle made by the directed line with the positive Z axis and also find direction cosines. Okay, how we can find? See here. This 30 degrees denotes what? It makes an angle with OX. Standard symbol is what? Alpha. Alpha is 30. 45 with what? OY. That means beta is 45 degrees. And gamma is gamma only. And then L is equal to direction cosines. Direction cosines becomes what? Cos alpha. Cos alpha is what? Cos 30. So what is cos 30 value? Root 3 by 2. So you do one thing, you make this angle is instead of 30 you take 60 degrees, okay? Instead of 30 you take 60 degrees. So cos alpha means cos 60 degrees. Cos 60 value is how much? 1 by 2. Then m is equal to cos beta, that is cos 45. Cos 45 value is how much? 1 by root 2. N is equal to cos gamma, but we don't know gamma value. So, but we know that L square plus M square plus N square value is how much? 1. Okay. So that is cos square alpha plus cos square beta plus cos square gamma is 1. So cos square alpha means 1 by 2 whole square 1 by 4. Cos square beta means 1 by root 2 whole square 1 by 2. Cos square gamma question mark, because we don't know, we have to find this equal to 1. So from this cos square gamma I am writing directly, see 1 by 4 plus, so 25% plus 50% only, 75%. 100 minus 75% is 25%, nothing but 1 by 4, implies that cos gamma is equal to what you will get? Plus or minus 1 by 2. Because cos square gamma 1 by 4 means cos gamma is plus or minus root of 1 by 4. Root of 1 by 4 is 1 by 2. Cos gamma plus or minus 1 by 2 means gamma will be either pi by 3 or 2 pi by 3. Because cos pi by 3 1 by 2, cos 2 pi by 3 is minus 1 by 2. So gamma value is maybe either pi by 3 or 2 pi by 3. So thus gamma value we got, and further what we have to find? Direction cosines. Then the direction cosines of the line are L. What is L value? 1 by 2. M value 1 by root 2. And N value nothing but cos gamma value plus or minus 1 by 2. 1 by 2, 1 by root 2 minus 1 by 2. Okay. So the direction cosines of that line are either this set or this set. Because cos gamma has how many values? 2 different values. Okay. That means there are 2 lines satisfying this condition. Okay. Because we are getting 2 different sets of direction cosines. So that means there are 2 different lines satisfying this given condition. Okay. Next. Suppose alpha, beta, gamma are directed angles. Directed angles of a line L. Okay. That means alpha, beta, gamma are angles made by that line with OX, OY, OZ. Okay. Then the question is, what is the value of sine square alpha plus sine square beta plus sine square gamma? We have to find this value. How we can find? So as alpha, beta, gamma are directed angles, then cos alpha, cos beta, cos gamma, these 3 quantities becomes what? Direction cosines. Direction cosines. Or you can write DCs. And what is the relation between direction cosines? Just now we have proved. So it's the sum of the squares is what? 1. Sum of the squares is 1. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. So now using this relation, we have to find sin square alpha plus sin square beta plus sin square gamma value. So sin square alpha in terms of cos square is 1 minus cos square alpha. Sin square beta can be written as 1 minus cos square beta. Sin square gamma is 1 minus cos square gamma. So why I am converting sin square in terms of cos square? Because we know this relation. This relation is in terms of cos. That's why I converted all these in terms of cos. So here 1 plus 1 plus 1, 3 minus cos square alpha minus cos square beta minus cos square gamma. If you take minus common, what will you get? Cos square alpha plus cos square beta plus cos square gamma. So 3 minus that value is what? 1. So 3 minus 1 is how much? 2. So the sin square alpha plus sin square beta plus sin square gamma is 2. This is also important result. So because these results are asking in a objective also. Okay. Next, one more result. One more result. What is cos 2 alpha plus cos 2 beta plus cos 2 gamma? Say in the same question. So we know this relation, then convert all these three in terms of cos alpha, cos beta, cos gamma. So cos 2 alpha is 2 cos square alpha minus 1. Cos 2 beta is 2 cos square beta minus 1. Cos 2 gamma is 2 cos square gamma minus 1. So 2 cos square alpha, 2 cos square gamma, 2 cos square gamma. Sorry, 2 cos square alpha, 2 cos square beta, 2 cos square gamma. 2 is common. If you take 2 common, what you will get? Cos square alpha plus cos square beta plus cos square gamma. So minus 1, minus 1, minus 1, minus 3. So this whole sum is anyway 1. So 2 into 1 minus 3. So 2 into 1, 2, 2 minus 3 is minus 1. Thus cos 2 alpha plus cos 2 beta plus cos 2 gamma value is minus 1. So these are the two important results. Just note down. Next, one more important problem. Okay, or like a note point. Okay, what are direction cosines of x-axis? X-axis you take here only one direction, positive x-axis direction. Okay, so line x-axis is also line only, na? So it also has in having the what direction cosines only, na? It has two sets only, na? But you take only one set. That means you take always positive side only. Okay, here direction cosines of I'm asking x-axis, but you consider only positive x-axis. So that means I'm asking direction cosines of OX. Since we know that this OX makes 0 with OX, pi by 2 with OY, pi by 2 with OZ. Correct? That means angle between OX and OX is 0. That is alpha value 0. Angle between OX and OY is pi by 2. That is beta value pi by 2. And angle between OX and OZ is pi by 2. So that is gamma is also Z. So gamma is also pi by 2. So these are the directed angles of OX bar. Then direction cosines becomes what? Cos 0, cos pi by 2, cos pi by 2. So cos 0 is how much? 1, cos 90 is 0, cos 90 0. So these are the direction cosines of x-axis. Similarly, direction cosines of y-axis. What you'll get? Tell me 0, 1, 0. Very good. And direction cosines of z-axis. Direction cosines of z-axis are what you'll get? 0, 0, 1. Because with OY makes 90 with OX, 0 with OY, 90 with OZ. So directed angles of OY are pi by 2, 0, pi by 2. Direction cosines. cos pi by 2, cos 0, cos pi by 2. So that is 0, 1, 0. Those are the direction cosines of y-axis. Similarly, 0, 0, 1 are the direction cosines of z-axis. Okay. Next, direction ratios or direction numbers. Okay. So direction ratios, and some authors they are calling direction numbers, and briefly or short form it is called DRs. Okay. So what is the definition of direction ratios? Suppose if L, M, N are direction cosines of a line, then any three numbers proportional to these numbers, are called direction ratios. Direction ratios of a line generally denoted by A, B, C. Okay. So these are the three numbers proportional to L, M, N. So how many numbers we can find proportional to given set of three numbers? Infinitely many. So that means here A, B, C, they are taking what? Infinitely many values. Okay. Direction ratios definition is what? If these three are direction cosines of the line, then any three numbers proportional to these three numbers are called what? Direction ratios. Okay. So we can find infinitely many numbers proportional to given three numbers. For example, L, M, N are the direction cosines. The proportional L, M, N are clearly proportional to 2L, 2M, 2N. Am I correct? Then you can take 2L, 2M, 2N or 2L, 2M, 2N are direction ratios. Okay. You can, if you multiply with 3, 3L, 3M, 3N. These three numbers are also proportional to L, M, N. That means these three numbers also we can take as direction ratios. Like this, if you write, how many you will get? Infinite. That means for given line, as it has two different directions, it has two different sets of direction cosines, whereas direction ratios are infinitely many. Okay. So one set of direction ratios are proportional to another set of direction ratios. Okay. Now from the definition, these three numbers A, B, C are proportional to L, M, N. Then obviously L by A value should be equal to M by B value should be equal to N by C. Am I correct? Okay, because these three numbers are proportional to these three numbers. Then obviously these ratios must be equal. Suppose all are equal to K, some constant K. Then what you will get? L is equal to A into K. M is equal to B into K, correct? L by A value K if you equate, if you cross multiply A, L is equal to what you will get? AK. M by B value K means M is equal to what you will get? BK. N by C value is K means N value what you will get? CK. And we know that L square plus M square plus N square value is what? 1. L square means what you will get? AK whole square. M square means what you will get? BK whole square. Plus N square means what you will get? C into K whole square is equal to 1. I am writing directly from this. If you simplify K square value, you will get 1 upon A square plus B square plus C square. Or K is equal to what you will get? Plus or minus 1 upon root over A square plus B square plus C square. Okay, if you take K value positive sign, then what you will get? L value what is L value? A into K. So I'm taking first positive sign. We got plus or minus. Now first I'm taking K value is plus 1 upon root over A square plus B square plus C square. Then in this case L value, what you will get? A into K. That is A by root over A square plus B square plus C square. M value BK, that is B into what is K value? Root over A square plus B square plus C square. N value C by root over A square plus B square plus C square. Next, if you take minus case, what you will get here? Minus. So overall what you will get? Plus or minus, plus or minus. So this you can use as a formula whenever if you know direction cosines A, B, C values, if you know direction ratios, whenever if you know direction ratios of a given line, if they ask find the direction cosines, you can use this formula. Okay. So for example, one example you take. Suppose if 2, 3, minus 6 are direction ratios of a line, then find the direction cosines of the line. So that means A value is given how much? 2, B value is how much? 3, C value is how much? Minus 6. Because they are the direction ratios, so we have to denote them by A, B and C. First you calculate root over A square plus B square plus C square. A square plus B square plus C square. So that is root over A square is how much? 4, B square 9, C square minus 6 whole square is 36. So 36 plus 9, 45, 45 plus 4, 49. Root 49 is how much? 7. So thus L value becomes what? Plus or minus A. A is 2 by root over A square plus B square plus C square value how much? 7. M value B plus or minus B means 3 by 7. N value plus or minus C is how much? Minus 6 by 7. Or if you multiply with the minus, plus into minus, minus into minus, plus 6 by 7. So that means what are the two sets of direction cosines? One set is 2 by 7, 3 by 7, minus 6 by 7. Another set is minus 2 by 7, minus 3 by 7, 6 by 7. These are the two sets of the direction cosines of the line. See, one set, if you take element, other set is minus L, minus M, minus N. So this is the method to find direction ratios whenever, this is the method to find direction cosines whenever direction cosines, whenever direction ratios are given, this is a method to find direction cosines. Sir, if direction cosines are given, how to find direction ratios? Use definition. You can take any three numbers proportional to direction cosines of the numbers. Okay. Next, one more important note point. If A, B, C are direction ratios of a line, then A I cap plus B j cap plus C k cap is a vector parallel to the same line L. Okay. Second important point, if A, B, C are direction ratios, then K into A, K into B, K into C are also direction ratios of L. Third important point, here remember K should not equal to 0. Third important point, suppose if the given line is passing through origin, if the given line passing through origin, okay, and let A, B, C, sorry, suppose if the line is passing through origin, then coordinates of every point on the line, nothing but DRs of the line except origin. Except origin, you take any point on the line L, then the coordinates of every point is nothing but direction ratios of that line, only if the line passing through origin. So if you take a point on this line ABC, then this ABC are the coordinates of this point, particular point P, and as well as this ABC themselves what? Direction ratios of the line L. So if you take any point like this, because as this line passing through origin, if you take any two different points on the line, okay, then the coordinates of one point are proportional to corresponding coordinates of other point in the same line, other point on the same line. So this is about direction cosines and direction ratios. Hope you understand the class. Thank you. Direction cosines and direction ratios.